Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development. You can WhatsApp us on this number 079 578 2908. Today's lesson will be on trigonometry, part 2. Last week you did trigonometry, part 1. And today we're going to be looking at equations and graphs. This is the topic, it's marks that you definitely need to get, with equations, which are very easy equations, and obviously graph, how to sketch a graph, and also how to interpret the graph when the graph is drawn for you. So those are the two questions, the parts of work that we're going to be doing. Now let's look at the objectives of this lesson to say by the end of this lesson, I want you to know the following. Now, at the end of this lesson, I want you to determine the solutions. Remember now we are doing equations, so we need to get solutions to those equations. But the nice thing about this is that you're only getting the solutions from 0 to 360 degrees. So in other words, we need solutions that are from 0 to 360 degrees. So in the trig equations. Number 2, you need to know how to draw the graphs of the following. Y equals to k sine of x, right? Where we have the parameter of k there. The next one is the y equals to k cos x. You also need to know how to draw the graph where k is our parameter there. Now, the other graph is y equals to k sine of x multiplied by k. Okay, so now the next one is the cos k times x, and the last one will be the y of equals to tan of x. So you must know how to sketch those graphs. Okay, the next thing that you need to know at the end of this lesson is to draw the graphs defined by the following. So you can see there's another parameter that we have put there, which is plus p inside the bracket and plus p inside the bracket for the cos. So it's for the sine and for the cos. You don't need to know for the tangent. Right. The last part that you need to know is how to interpret the graphs. The graphs are given to you. They are drawn for you. So for you need to know how to just do the graph. Have your calculators handy so that you are able to can calculate the points on that graph. Okay, some quick notes on the trig equations. Is a trig equation. So I've put in 4 points there to say the type of questions that we're going to get in an exam. So in class, check those types so that you practice those types. Type number 1 is when I'm giving a ratio and I also have a value. So I've got a ratio and a value. An example to this is that if I've got solve for x, then I must have a ratio. Maybe for instance, I've got a sine of a theta, it's equals to 0,5. So you can see I've got a value, I've got a ratio. So these are the type of questions that we're going to be looking at first. Type 2 is when you have a ratio and a ratio. So in other words, you might have the cos of theta, it's equals to maybe the sine of 125 degrees. So therefore you are having a ratio and a ratio. So then we need to look at also those type of questions. So remember in our trigonometry we also have the core functions. So the cosec, the sec, and the cot. Those are the 3 core ratios that we have. And we must also know how to find an equation. I mean, so the solutions for those trig equations where you're given the sec, the cos, sec, and the tangent. The next thing that we know now is that the domain, in other words, all our x values must be between 0 degrees and 360 degrees. So we cannot have a value which is over 360 degrees or a value which is less than 0. So we are only working in our interval between 0 and 360. So our answers must always be in that range that we have that value to be between 0 and 360 degrees. The other part that we need to understand there is that the reference angle is always positive. So we're going to work with reference angles that are positive. So you don't need to have a reference angle which is negative. And as I said, have your calculators handy so that when we do this, and I show you what the negative, if I've got a negative, what are we going to do with the negative? All right. Okay. The first part there will be looking at the trig ratios that will be given, and what is the implication of the answers that we're going to be having, or what are the steps that we're going to take when getting the angles. Remember, we're working in the 4 quadrants that we have done last week. Now we have the first quadrant will always be the angle theta, which is an acute angle. So in the first quadrant, we're having an acute angle, which is the angle which is between 0 degrees and 90 degrees. So that's, we call it theta. In the second quadrant, remember, you're working with an angle which is more than 90 degrees and less than 180 degrees. So why the 180 degrees minus, it is what we call a reduction formula that we have done in detail last week. So the reduction formula will help us to get our solutions when we're doing trig equations. So it will definitely help us there in the second quadrant. So we say in the second quadrant, the angle, we need to check our CAST, as you remember that. So it will be the cos being positive in this quadrant, all being positive in that quadrant, the sine being positive there, and the tangent being positive in the third quadrant. So we're having 4 quadrants. So it means that if I say cos is positive in this quadrant, the rest of the ratios, which are the sine and the tangent, are going to be negative. If I say all are positive, I'm talking about all trig ratios, the sine of an angle, the cos of an angle, the tangent of the angle are all positive in that quadrant. Here I'm talking about the sine being positive, meaning that the cos and the tangent are negative. In the third quadrant, the tangent is positive, sine is negative, cos is negative. Now, if I'm given the ratio and a value, remember this is type 1. It means, and now I can see that my A value is a positive value. Then I'm going to check on my Cartesian plane to say if my A value is positive, in other words, if my value here is positive, what should I look for? Where will my solutions be? Remember, I'm working from 0 up to 360 degrees. So where will be my solution where the sine is positive? So I know my sine is positive in the first quadrant, where everything is positive. And again, it's positive in the second quadrant, then I must use 180 degrees minus. Now look at this. How am I going to get the value of the angle? I must write the angle. Then from there, say equals to. Then I take out my calculator. Then I say shift sine of the value that has been given. So in other words, if I'm going to, let's say for instance, I'm given the value here is theta, it's equals to sine, shift, maybe the value there is 0.5. So I'm going to say shift sine 0.5. Then from there, I'm going to get the value of that angle. Okay, so after getting the value of that angle, I know that in the first quadrant it's theta, so that value will be correct because that will be in the first quadrant. But now I need another value which will give me 0.5. So you see when we're doing graphs that this is what we'll be talking about again. Then I need another value which is theta equals to, where is this the sign positive again? In the second quadrant, it's 180 minus the angle that I got there. So I subtract that angle here, and then from there I'm going to get my value of theta in here. So we'll do an example next slide, and then you can see what I'm talking about. Now, when the A value it's negative, in other words, the A value is less than 0. So say, for instance, I've got sine of theta equals to negative 0.5. Now you can see the A value, which is a negative in this case. We go to our Cartesian plane, we check where is the sign negative. Then we check the sign is negative where the tan is positive and where the cos is positive. So it means my solution will be, so I'll get theta equals to sine, the inverse of sine. So there I don't put negative inside the bracket, remember? Because my reference angle, as I said, must be a positive value. So I get a positive value, and then after getting the positive value, then I check this is not going to be my solution. I check where the sign is negative, and I use the reduction formula. You can see why you have done the reduction formula. Then I'm going to say my solution for that will be theta will be 180 plus that angle that I got here. And theta will be 360 degrees minus that angle that I got there. Then I'll have my answers there. Okay, so I'll have my answers here and there. So it's not 0, but that will be my solution there. So this is very important that you understand first before then we do the activities that I'm going to be that are going to follow now. Now, in the cos, we do the same thing with the cos and say if the value there is greater than 0, in other words, if the value is positive, where is the tan positive? In the fourth quadrant, and the first quadrant. So in other words, the angle that I get here will be correct, and the other angle will be 360 degrees minus. And that angle, we call it a reference angle. Okay, that answer will be the same thing. So therefore, why 360 minus? Because cos is positive here, and the value of that is positive. If the value of A is negative, in other words, if I've got a negative value there, what do? Where is the cos positive, negative? The cos is negative in this quadrant and in that quadrant. So meaning that my solution that I'm going to get there, this angle will be my reference angle. So in this case here, this one will be my reference angle and also going to be my solution. Right. But in this case here, this one will be the reference angle only. Why? Because cos is not negative in the first quadrant. Cos is negative in the second quadrant and in the third quadrant. So I'm going to have my solution as theta equals to 180 degrees minus the reference angle. Okay? Theta equals to 180 degrees plus the reference angle. So these are my two solutions that I'm going to get. Okay, when you do the activities, I'll come back to this, then you'll understand it much better. Now, let's look at the tan. With the tan, when A is negative, it's positive. When A is positive here, what solution are we looking for? The tan is positive in the first quadrant and again in the third quadrant. So my solution will be theta equals to the reference angle will be my solution. Also, it will be a reference angle and it's also going to be my solution. Right. The other solution will be theta, it's equals to 180 degrees plus that reference angle. Okay. So now, I've got two solutions there. So in the third one, and the next one there, the A value is now negative. What type of solution am I going to get? So I'm going to get, now where is the tan negative? So the tan is negative there, and it's also negative there. So meaning that the angle that I'm going to get first by using my shift tan, it's going to be a reference angle. It's not going to be my solution. So now for my solution will be theta equals to 180 degrees minus my reference angle. And again, my other side will be 360 degrees minus the reference angle. So I've got two solutions there. Here I've got two solutions. So you see we have two solutions when we do dealing with this type of questions. Right. Now let's see the first activity that we need to do that talks to this. The first thing that you need to understand is your interval, because that interval tells you how many solutions are going to have. So in this case, if I've got from 0 to 360, it means I've got my solutions from 0 degrees right round to 360 degrees, which then tells me that as I know my casts, I know where the sign is positive and negative in my quadrant. So when you're doing this type of questions, draw your cast and also check your 180 your reduction formula. 180 degrees minus 180 degrees plus. You've got 360 degrees here. It's 360 degrees. Sorry. You've got 360 degrees there, so it will be 360 degrees minus. Sorry. Okay. So draw that so that then you are able to can use this this reduction formula. Now, let's look at that. Now we have got type 1 where we're given the ratio and a value. See, that's type 1. What type of a value do we have? It's our A less than 0 or greater than 0. I can hear you say greater than 0. It's not negative, it's positive. So if it's positive, what do? We check that. A is greater than 0. So if A is greater than 0, where is our solution? Our solution will be that reference angle and also 180 degrees minus. Why? Because the sign is positive in the second quadrant. Already we've got the answer here. So now what do we do first? You write X, you put equals to, make sure that we don't have a value, anything there. So then you have X, it's equals to the inverse of sine, then you put 0.745. Okay, and then you go to your calculator. So if I go to my calculator, in my calculator, I'm now going to say shift shift sine, and I put 0.745. So I'm going to my calculator, I'm going to say shift sine 0.745, and I close my bracket, and then I'm going to get my answer here. We'll write it correct to one decimal place. So my answer is going to be 48.2, correct to one decimal place. Remember now it's an angle, it's a degree. So if there is a degree, in which quadrant is that angle? In the first quadrant. In the first quadrant, is the sign positive? Yes. So now I know this is one of my solutions. But I'm not done, because I need solution all around here from 0 to 360. So I must go and check where the sign is positive again. So my sign is positive in the second quadrant, but in the second quadrant, what do I know? I need to use the reduction formula. X is equals to, so I'm going to say 180 degrees minus. This is my reference angle. My reference angle will always be my acute angle, which is the angle that is less than 90 degrees. In this case, this is my reference angle, and also it's my solution, my part of my solution. Now here I'm going to say 180 degrees minus 48.2 degrees. So if I subtract the 180 from that angle, then the answer that I'm going to get is 131 degrees, 8. So my x value will be this, and my other x value will be that. So now you can see I have two solutions. Now, what will be the mark allocation there? If I need to give marks to this, then it means that I'm going to give you a mark for finding the reference angle. Nice. One mark for finding the reference angle, because that's just calculator works. It's straightforward. So you just go to your calculator and press that. I'm going to give you another mark for writing that other solution, which is 131, knowing that there is 180 degrees minus the reference angle, and that is so. All in all, I think that 2 marks will be enough for that question, because you just go into a calculator, doing that, and then substituting into that, then knowing that that will be 180 degrees minus that to get that final answer. And that final answer will be 131.8. The other one is 48.2. Right. Going right along. Let's check the next one. Now we have something else here. Now remember, in that first one we have the x, the sign of x. Now we have the sign of a something there, which is 3x minus 50. And again we have a negative, and we have a cos. Okay, but the solution is right round, so it's from 0 degrees to 360 degrees. So meaning that we have to have two solutions. But now that is not a trace match. Let's see. Now remember, this whole thing there is an angle. So here we can just, it's an angle. So we must not divorce it here. So we must divorce it at the end. So we're going to try to divorce this one at the end. But how are we going to do that? So if I've got cos of 3x minus 50 degrees, the 3x minus 50 degrees, it's compound. So it's going to stay like that until at the end where we can decide in which quadrant we are going to work with. Now, very, very important. Please pay attention here. Now, the a value here, it's negative, it's less than 0, meaning that our solution will be in the second quadrant and also in the third quadrant. So meaning that our reference angle will not be a solution. So we're just going to call it reference angle. It's not part of our solution. Okay. Now then, we are going to then go to our calculator again and say, with our calculator, the 3x, remember this angle, this is the angle. So that is my angle. In my calculator, I'm not going to put the negative. I'm going to ignore it. What does that negative tells me? It tells me in which quadrant will tangent, I will cos B. So the cos will be negative in the second quadrant and the third quadrant. So I'm not going to use that negative. I've already used it. I already know where my solution is going to be. So I'm just going to say shift cos, then I put this number is 0,219, close my bracket, and the answer that I get here is 77. We're going to work correct to one decimal, so I'm going to say 77,3 degrees. That is my angle. This angle here, I'm going to call it a reference angle. Please do not be tempted to find the value of x by transposing the 50, the negative 50, and then dividing everything there by 3. It will be incorrect. So there your reference angle stops there. That's where because that is your compound angle. That is compound. It's something that is one here. It's an angle. All right. So now, then I'm now deciding where is my solution. Now, I prefer doing it in a table. So in my table, I'm going to draw a table here and say, where is the the cos negative? In the second quadrant, where I use 180 degrees minus the reference angle. Where again is the cos negative? In the third quadrant, where I'm going to use my reduction formula 180 degrees plus the reference angle. All right. Now, once I've done that, then I'm going to get my solution. Now. Now I'm going to say now, the 3x minus 50 degrees, it's equals to. Now I'm going to say 180 degrees minus, what is my reference angle? 77,3 degrees. Hope that is very clear. In the third quadrant, what do we use? We still use our angle here, which is 50 degrees, equals to, what do you say, 180 degrees plus 77,3. In this case, we're now going to solve for x. You see where we solve for x. I did not solve for x in this step here. I only solve for x in the next one, where I know that the cos for that angle will be equal to that. So here, what do I do now? I'm first going to subtract the 77.3 from 180, and then I'm going to get 102.7 degrees. All right. I still keep the 3x minus 50. Then if I keep my 3x minus 50 on this side again, I'm now going to add 180 degrees plus the 77.3. And the answer that I'm going to get there will be 257.3 degrees. Right. Now I can work that one out. I can first add the 50 degrees. Now I'm solving for x. And then I'm going to have 3x here. It's equals to 307.3 degrees. Then how am I going to get the value of x? I'm now going to divide that by 3. And my answer is going to be 102.4 degrees. See, that is my final answer for that one. For the other part here, I'm going to say 3x is equals to, it will be 152.7 degrees. Then divide that one by 3. So it's 152.7 degrees. And I'm going to divide that one by 3. Then the answer that I'm going to get there will be x is 50.9 degrees. So those two are my solution. So you can see, if I go to my calculator now, and then if I go to my calculator and try and substitute these values here, I'm now going to try to substitute them. So how do you substitute them? You are going to say cos, inside the bracket there you've got 3 multiplied by, I'm substituting 50.9 first, multiply by 50.9. And then from there, I'm going to subtract the 50 degrees, close the bracket. Then my answer that I got on my calculator, it's negative 0.2198462. And correct to 3 decimals, there will be 219. Okay. So if I substitute, for instance, 102.4, I'll say cos, open bracket. Then I'll say 3 multiplied by 102.4. Now I'm checking my answers. Then I'm going to say minus 50. Close my bracket. Okay, minus 50, 102.4. Then I'm going to get that answer of minus 219. Now let's check. So if I say 307.3 divided by 3, so the answer was that. So I can get my answer to be closer to negative. Remember, we have, most of the time we have a rounded off here. So if I don't round off and I put all those values in there, so I'm able to can get the exact value. Remember, we are rounding off most of the time there. So our answers are going to be 50.9 and 102.4. You must go and check them in your calculators. Okay. All right. Now here we have another type here. So remember, we had a value, a ratio and a value. And the type 2 was a ratio and a ratio. So with the ratio and a ratio, what are we going to do? Now we've got something. Our calculators do not have sec of x. Our calculator do not have the cosec. Now we are having a challenge. Now, how am I going to get through to this challenge? Okay, the sec of x. What do I know? First of all, what do I know about the sec of x? The sec it's a reciprocal of cos. So meaning that if I've got sec of an angle, I can write this one as 1 over cos of an angle. So no problem. So what I can do is, in this case, I can change this to 1 over cos of x equals to. If I've got cosec, I know cosec is going to be of an angle will be 1 over sine. So here also I don't have a problem. So I'm going to write 1 over sine of 75 degrees. But there's a negative. Okay, so with my calculator, I'm going to go to my calculator, and then I'm going to now say 1 divided by sine of 75. Close the bracket, and that my answer there is going to be 1,035 and some values in there. Okay. Now I've got 1 over cos of x. But remember, I need that ratio. I don't need the ratio which is 1 over. I need a ratio which is going to be cos of, so that I work with cos of. Right. So now, how am I going to then change all this? No problem. I know that this one is over 1. I can quickly cross multiply and make cos the subject of the formula. Right. Okay. So now I just want to take it in an easier way, so that you understand, or how did we come to that. So I'm going to have 1,035 multiplied by cos of x, it's equals to 1. So I'm going to have cos of x, if I divide both sides by 1 by 0,35, right? So you see now I've got cos of, right? Because if I say shift cos and I say 1 comma, oh, then I have a problem somewhere. I'll have a problem. My calculator is not going to give me an answer for that. Right, so now I have that cos x equals to 1 over 1 comma. Okay, oh, I should have seen that here, that if I, and there, if I want to change, if I wanted to write this cos, I should have swapped this. Oh, no, I didn't see that. So now I need to just swap those two and write that one as cos over, cos x equals to 1 over that. So I can go to my calculator. I don't need to stress with it. Now I need the cos. So if I can check now here, that one was a negative, sorry. This is a negative. So there we have a negative. That answer is a negative. What do I know about the cos negative? So if my value is negative, cos will be having two answers. The reference angle will not be the answer. We'll have 180 degrees minus and 180 degrees plus. So what am I going to have in here? So I'm going to go to my calculator, and my calculator, I'm going to say, now we're going to say shift cos, don't worry about that, negative, remember the negative gives us the quadrant. So I'm going to say 1 divided by 1,035. So I then close the bracket, move my cursor, close the bracket, and the answer that I get here, corrected 1 decimal place, it's 14.9 degrees. So that is the angle that I got. So it's 1 over that. Okay. Now, fair enough. That angle here is my reference angle. Remember, reference angle can never be negative. We don't do negative angle, so it can never be a negative angle, please. So now what is my next step here is to get my solution. So how am I going to get my solution? So I'm going to say, right. So remember, cos is negative in which quadrant? 180 degrees plus my reference angle, which is my first value of x. Then I'm going to work out this one. It's 180 plus my reference angle. What is my reference angle? It's 14,9 degrees. Then I'm going to say that one plus 180 degrees. So my answer is going to be 194,9 degrees. Now the other answer will be 180 degrees minus my reference angle. Should have started with that. So what am I going to get if I subtract my 14.9? Okay, so I'm going to say 180 degrees. Let me just clear that. 180 degrees minus 14.9. Answer that I get here is 165.1 degree. So I've got two solutions here, and that part here is a reference angle. It is not a solution. Why? Because it is in the first quadrant, and cos is not negative in the first quadrant, it's positive. So that cannot be our solution. So our solution will be this, and that will be our solution. So for me to mark this one, what I can first do is for you to know that that one can be changed like that. The second mark for me will be to know that this cos can be written like that. My next mark there will be the solution for the reference angle, which is not our answer. For that sum is just the reference angle. My next mark it will be to know to get the first answer, which is 180 plus. The next one will be to know in the next answer there, which is that. So wow, that question can carry up to 5 marks. Nice 5 marks. Nice life problems in mathematics. Right, in technical maths for this matter. Activity number 4, I'd like you to do activity number 4, but yay, watch that. The interval that is given is 0 to 90. I'm going to give you some minutes to do that question. I'm going to give you 3 minutes to do that question. So can you take 3 minutes to do that question? Okay, welcome back. Let's see what you have done there. I hope you understood what has happened there. X, element of 0 degrees to 90 degrees. This simply means that we are working from 0 to 90. Our answers must be here. So we can't have that answer more than 90, more than 180, and less than 360 degrees there. So I can't have an answer which is more than 90 degrees. I can't have an answer which is more than 180 degrees. I can have an answer which is more than 270 degrees. My answers must be between 0 and 90 degrees. So I'm working in the first quadrant where all ratios are positive. Okay. So I hope you did not go to check where the sign is positive and all that. Right, now let's see. First of all, remember, the angle must be on its own. I mean, the ratio must be on its own. Nothing else. It must be on its own. The sign of x must be on its own. Meaning that 2, what do you do with that 2? What did you do? We divided both sides by 2. Okay, so that we have sine x on its own. Then if I divide that by 2, I get 0.37. Hope you also got that one. Okay. Now what do we do then? I'm now going to say x is equals to sine, inverse of sine, which is 0.37. Here I put 0.37 there. I go to my calculator and I say shift sine 0.37, and the answer that you're going to get, you got, it's 21.7 degrees. Should I do anything with that? Nothing. Remember that answer there, it's going to be my reference angle. In this case, I don't need a reference angle because I'm only working in the first quadrant. Then that one is a solution. Yes, it is my solution. I'm done with it. Okay, quite an easy question there. First mark will be for dividing by 2. The second mark is for getting the answer. So there's 2 marks. Okay, now you wonder, why did you give us 3 minutes to do just a simple question like that? Just wanted you to check in which quadrant. Check the question first. Don't just start by doing the question without having read the instruction, because that instruction tells you what to do. Because I know in this case you are going to say, oh, the second quadrant sign is negative, is positive. Can't we use 180 degrees minus theta and we use the reference angle? You'll be going too far. That answer there stops there because of the interval. So the interval is very important. Read your question and then from there do what is requested of you to do. Okay, this one here. It looks somehow lot of things in there. Lot of things in there, but I don't think it's a train smash. Let's see. First of all, let's check what the interval is. This angle here, which is a compound angle there, right? I always want to call it theta as an angle. And then from there, we say it's an element between 0 and 180. So meaning that in my interval, I'm working from 0 degrees to 180 degrees. Okay, so in this case there, so which quadrant am I working with? I'm working with the first quadrant, second quadrant. I don't need any answer that is more than 180 degrees. So here, nothing. Here, nothing. I don't need any answer that is more than 180. So you can see that the interval is very, very important. Check your intervals before you do these questions. First of all, I don't need anything next to cos. There, that thing, I don't need it. I don't need that number. So what should I do if I don't need that number? I'm going to divide both sides by 4. Okay, so I'm going to divide both sides by 4. So I'm going to say 2,178, divide that by 4. So the answer that you can see the answer that I'm getting there, there's nothing that says 1 comma something. Okay, so I'll discuss that in the graphs. So 0, 5, 4, 4, 5. So what am I having here? I'm having the cos of, remember this 2 theta plus 20. That angle, where do I divorce this? I divorce that when I'm getting my solution at the end, where I've already checked where the cos is positive. In this case, the A value is positive. I must then divorce it at the end where I get my solution, where I check where the cos is positive. In this case, where is the cos positive? In these two quadrants. You see, I'm talking two quadrants. I'm not talking this one and that one. Where is the cos positive? Only in the first quadrant where everything is positive. Can I work here where the cos is positive again? No. The reason being, my interval says from 180 degrees to 180 degrees. In the two quadrants, the place where the cos is positive, it's in the first quadrant where everything is positive. Now, what do? Then I'm now going to get my solution. Okay, I'm going to get my solution. How am I going to get my solution here? So I'm going to say, go to my calculator and say shift cos. Then what do I put? 0,5445, close the bracket. Then my solution, what will be my solution? 57,0 if I'm working with one, correct to one decimal place. Okay. In this case here, what do I have? 2 theta plus 20 degrees equals to that. But I know this is in the first quadrant, meaning that cos, in this case, cos is positive in the first quadrant. So I just get my value of theta with this one. So I'm going to say 2 theta plus 20 degrees, it's equals to 57 degrees, 57.0 degrees. Let me subtract that 20 on this other side. So I'm going to say subtract 20 degrees. You can see now I'm working with angles here. 2 theta equals 2. If I subtract 20 degrees from that, I'm going to get 37,0 degrees. Then what can I do? Then divide both sides by 2. So I divide that angle by 2. So I'll get 18,5 degrees. So that is my solution. Can you see my solution? It's somewhere there in the first quadrant. The first quadrant, the cos is positive. Then that answer will be correct for me. And it will be tricky if they give me minus, then I wouldn't have done it, because then I know in that quadrant, the cos can never be, the cos will be negative in the second quadrant. So meaning that I'll have how many answers? I'll have I'll have one answer also, because I'll say 180 degrees minus my reference. I hope these questions are clear, and I hope and trust you'll be able to do this type of questions. Practice them. Practice all these questions. Practice all type of questions. So got type 1 and type 2. Group them as you practice. Say this is type 1 questions. Let me practice this type 1 questions. Important thing is to look at your interval. You practice with your interval. Make sure that when you're practicing these questions, you draw your Cartesian plane with your cast diagram and your reduction formula. And also know that if it's negative, if tan is negative, in which quadrant am I going to be? Sine is negative, in which quadrant am I going to be? And sine negative, in which quadrant will I be? So this is basically what we're going to do. The tan will also work in the same way that we're going to do. So let's get to the next part of work. Let's get to trigonometric graphs. Now, with the graphs, we are now going to look at the graphs that we're going to be drawing. We talked about that. Okay. We talked about this. We talked about that. We talked about that. We talked about the tangent of x. The graphs are only going to be drawn from 0 degrees to 360 degrees. Nice, because then I know that I'm starting at 0, I'm finishing at 360 degrees. But still with this one, you must check what is given. So you must check what interval is given. Sometimes they might say you must draw the graph from 0 to 180, from 0 to 300, to 270, or from 0 to 90. So you must first check what type of graph are we going to draw. Now let's look at this one. Now it says, sketch the graph of, there's brackets here, sorry. Now sketch the graph of f equals to sine of 2x. And again, you must sketch the graph of cos x plus 45, where x is an element of 0 degrees to 180. Now you can see the interval has been given to you. Okay, so given the interval, so in other words, my graph must be, if I draw my Cartesian, the nice thing in the exam is that the Cartesian plane will be drawn for you. So no need to stress. Cartesian plane is drawn for you. You don't need to stress. So you have your y values, you have your x values here, right? Then from the 0 there, you have got a 1 and a 2, maybe a 1 and a 2. I'm going to explain this now, right? So now I can see in this graph here, we have a value 1. What does that value mean to us? It means that it will tell us how high and how low the graph will go. So if I've got a 1 here, it means that I'm going to talk about how high and how low the graph is. And I hope and trust in your classes, your teachers, they've explained that, and they called it an amplitude of that graph. So that is your high point and the low point on that graph. The maximum graph, the maximum and the minimum of that graph. So if it's 2, it means that the graph will go up to 2 on the y, and it will go down up to -2, the minimum. So in this case, they said it's 2, it's 1, so it will go up up to 1. So now let's see. I've seen a 45 there, so it is up to 180, so I can go 45, 90, 135, and 180. So I can stop there. So I can say 45, I can say 90, say 135, and I can say 180 degrees, because my graph must stop there. So in this graph, so remember, if I draw that graph, so I see there's a 2x there, so I'm going to talk to that. So now that will indicate also our period. So how is it going to work? So I'm going to say, because the period of this graph, it means that the period of the graph will be 360 degrees of the sine graph and the cos graph. So meaning that if I divide this by 2, I'm going to get 180. Okay, so I'm going to get 180. So if I need, how many quadrants am I going to have? Then I can divide this by 4, and I think 180 degrees divided by 4 will give us 45. Then that is why there I got 45s there of interval, so that I must be able to draw a proper nice graph here. Okay, the easy way to do it will be the following. What I'm going to do is, I'm go by using a calculator, and I hope you have your calculators with you. An easy process to draw these graphs. First of all, when you're using the sharp calculator, I'm going to work with a sharp calculator. You'll first go to your mode. So I've written the notes there. You first click your mode. That's your mode on the calculator. Then you choose number 2, which is going to be a table. So you can see there, number 2 is a table. Okay, so when you choose the table, the calculator, then you're going to have your next step. Once you've chosen the table, you're going to have your next step, which is going to be, so I'm going to be doing here on my calculator, then I'm going to have my step. So I'm going to have my mode, and I'm going to have that. So press sign on the calculator, that's sign, so you press your sign. Then you press 2. Now you need your x on a calculator. So you look for x on a calculator. So on my calculator, I can realize that the X there is blue. Okay, it's greenish or blue, green. Let's say green. Now, if that is green, you look at these two buttons here. See, we've got alpha, we have got second function. The alpha is green and the X is green. It means that to get to your X, you must then press the alpha button. So once I press the alpha button, then I'm going to press my RCL. So my RCL will give me the X. So therefore, then I press equals to, then I'm pressing equals to again. Now, what is going to happen is the graph wants to know where, the calculator wants to know where you want to start. So where do I want to start? My graph, they said, is going to start at 0. So it's from 0 degrees to 180 degrees. I will not worry about ending. So it will 0 degrees to 180 degrees. So it will say, where do you want to start? So I want to start at 0. So I will press my 0. Okay. Then and press equals to. Remember when I press, I always press the equal sign. After that, I then put my step. Now it wants me to tell it what are your steps? Is it 45? In this case, what did we say our step is? 45. Because remember I said 2x, I mean 2x equals to 360 degrees for the period. And I said, okay, so for the period, and I said divide this by 2, you get 180. For step, you must know that there are 4 quadrants. You divide by 4, you get 45. So my step will be 45. So therefore, my steps are going to be 45. Then, so I'm going to press 45 and press equal sign. After that, then the calculator is going to give me a table. Very important. Once it gives me a table, it's going to tell me if at the x value on my Cartesian plane, at the x value of 0, if the graph is at 0, then my answer is going to be 0. So in other words, my y value will be 0. So y and x, 45, 90, 135, 180. So now 135, 90 and 45. So now if I'm at 0, my y will be at 0. If I'm at 45, it will be 1. So it's 45. Here's my 1. So I'll go and put a point there at 1. If I'm at 90, I'll be at 0. Okay. Right? If I'm at 135, I'll be at minus 1. So I'll be at minus 1. Sorry, at minus 1. Right. If I'm at 180, I'll be at 0. Okay, so if you go with a calculator, then I can just smoothly join these points and I'll draw my graph. Please, my graph does not have arrows. I don't put arrows, I just put a full stop there to show that this graph stops there because it's from 0 to 180 degrees. Then use the table to go up to 180 degrees. You stop there at 180, then you have got a proper graph. There's no child without a name. So if that graph is F, we're going to write an F here. Okay, on top of that graph. All right. Here's the graph. Here's the Cartesian plane to draw that graph. So now remember, I want to draw the two graphs together. So at 0, we said at 0. I'm going to put this one at 45. This one at 90, 135, and 180. Right. So we said 45 is going to be 1. So here's my 1. Here's my minus 1. So at 45 is going to be 1. At 90, it was 0. At 135, it's minus 1. At 180, it's 0. So then I'm going to quickly draw my graph nicely and then join this point. Please do not use a ruler to draw this graph. Okay, it's a free hand. Please join the points by using a free hand. So now I'm going to draw the graph of cos x plus 45. So in other words, I'll have cos. So at 0, it's going to be cos of 45. Okay, so at 0 is going to be the cos of 45, and the cos of 45 will be 0,7. So from 0, it will be 0,7, so meaning that my graph will start somewhere there. Right. Okay. Now at 45, it will be 90, so I'm going to have the cos of 90. So cos 90, so it will be 0. So in this case, at 45, it's going to be 0. Right. Then we have it at 90, so 90 plus 45 will give us 135. So I'm going to have the cos of 135. It is going to give me negative 0,37. I mean 0,7, which at 90 will be somewhere there. So I'm just going to put a cross there. At 135 is going to be 135 plus 45, which is 180. So it will be the cos of 180. In this case, it's going to be negative 1. So here it's going to be negative 1. So that's where the graph is going to be. Right. And then from there, I'll have at 180, it will be 225. So it will be cos of 225. And that graph there is going to be negative, comma, 7, so it will be somewhere there. So for instance, then I'm going to try and draw that graph. I'm going to draw it like this. Please don't do that. Just use a different color. Then I'm going to go do that. Then from there, my graph is going to stop here. That's where the graph stops. So the graph of x plus 45, the shift to the left, because plus 45 is shift to the left. So if I write, but remember we don't do the values on the other side, so we do it from 0. So that's why we have the graph like that. There's no child without a name. This graph here is F, that graph there is G. So I've got F graph and a G graph. My interval is correct. It's from 0 degrees to 180 degrees. No problem with that. So we practice by using a calculator. If you don't want to use a calculator, you can draw your own table. Please make things easier for yourself. You can either use a table. Then from there you put your values, but you must know how to do that. So if I get my x values here, so say I start from 0, I go 45, I go 90, I go 135, I go 180 degrees. Then from there, I know I want the values, I want the graph of sine of 2x. Maybe I can just extend this and then do the cos of x plus 45 degrees. So then I can take my calculator and do it step by step when you start practicing. Then you say sine 2 times 0, then you'll get a value. You say sine 2 times 45, you'll get this value. Sine 2 times 90, you get that value. Sine 2 times 135, you get that. Then you get that. Then from there, you plot your graph according to the points that you are having. You go to x plus 45, you say cos, open bracket, 0 plus 45, 45 plus 45 until you get all the points and you put there. But the calculator can do that for you. So you can have 2 graphs in one. Please practice. Remember that graph, as I say, the high point will be, the turning point there will be 1 and 0 at that point. Here it will be minus 135 and minus 1. Okay, so here if I want to write down the point, I'm going to say its x value is 45, the y value is 1. If I like to write the point there will be 135 degrees for the x value. Remember these are x values, and the y value will be negative 1. Okay, so when you do interpretation, you see sometimes they give you these values and they want you to get the value of A. Okay, which is the amplitude. So this is the graph that is shifted. This is the graph that has got a period of 2. Great. So go there, get questions on graphs, on how to draw the graphs, practice how to draw the graph, practice how to draw the tan graph, practice how to draw all those other graphs. Now in this one, it's the same one. Now let's look first here. What is given here? You are given the interval. So they say you must draw your graph from 0 degrees to 270 degrees. See? Right. So what do I know about these two graphs that has been given. The first one is f of x equals to tan of x. Oh, we haven't drawn the tan graph. Oh, now let's go. Let's see. How am I going to draw my tan graph here? Oh, what do I know about the tan graph? You still remember? We have what we call asymptotes. Asymptotes. So we have the asymptotes. How am I going to do my asymptotes in the graph? So, right. Now listen to this carefully. The graph of tan is not defined at 90 degrees and at 270 degrees. So the first thing that you do with a tan graph is to draw a dotted line on the 90 degrees where it is not defined. All right, but first check if it's given as tan of 90 degrees, tan of x. The next line that we're going to draw is at negative 270. So I know you're checking that tan 90. Oh, it says maths error on your calculator. All right, so these are called asymptotes. In other words, the tan graph will never ever touch those lines. Okay, first of all, now we're going to our calculator and say, so you can do it as a table, but I'm going to do it per value there. You still remember this one, we have drawn that graph sine of 2x, but we stopped it at 180, so we'll just continue with it. So remember we said at 0 degrees it was 0, at 45 degrees it was at 1, at 180, at 90 it was 0, at 135 it was negative 1, at 180 it was 0, obviously at 225 it will be 1, and then at 270 it will be 0. So now I'm going to draw that graph nicely there. Right. Okay. So that is my graph of G because we've already drawn it. Okay. Now the tan graph. How am I going to draw the tan graph? Now I'm going to my calculator and say, what is the tan of 45? So in other words, my x, I'm replacing it by 45, by 90, by 135, and all that. So now if I say tan of 45, oh, I get 1. So it means that at 45, the tangent will be at 1. At 0, it will be 0. All right, I've got only 2 points there. Okay, now let's check. Tan 90, it's undefined. Then I go to tan 135. Tan of 135, I get negative 1. So tan of that will be negative 1. Then I go to tan of 180, tan of 180 degrees, then I get a 0. Then I go to tan of 225, tan of 225, then I get a 1. Then from there I go to tan of 270, I get a undefined. But now this point, how am I going to draw this point? Now I'm tempted to follow this graph like that with those points, but no. The easy way to draw this graph is to do this. Pay attention now. If I take any value that is next to 90, just to make that graph correct. If I take any value which is next to 90, say for instance I take 80, tan of 80. Tan of 80, can you see it's 5 comma something? Now, if I say tan of 70 for instance, it's 2 comma something. So tan of 70, maybe 70 is somewhere there. It's 2 comma something. So it will be somewhere there. So can you see where my graph is going? If I say tan of 90, as tan of 89 for instance, tan of 89, you see 57 comma something, which is somewhere up there. So meaning that this is where my graph is going. So I'm going to draw my graph like this. So it goes like that, but it doesn't touch that line. That is my tan graph. Now, if I say, for instance, I take the tan of 91, just after 90, I get negative 57, which is somewhere down here, somewhere down there. Okay, so if I take tan of 100, what am I going to get? Negative 5.7, which is somewhere there. Tan of 100, somewhere there. So meaning that my graph is from here. So my graph is going there, there, but it does not touch that line. See? And that is my tan graph. So my tan graph, it's an F graph. I must give it a name. But this tan graph, the nice thing about the tan graph, it's got arrows. I know you love arrows. But with the sine graph and the cos graph, they stop. The tan graph will always continue, because if I get the tan of 269.999999, I'll still get a solution for that. Okay, so it's a continuous graph. So that graph does not touch those lines. Please make sure that but please, I know some of you, when they draw the tan graph and they've got a asymptote, then they draw it and they want to move away from the turning point. Don't do that. Okay, don't do that. Don't move away from the asymptote. You must go closer and closer and closer to the asymptote. Right. The last activity that I'm going to do, it's an interpretation of these graphs. You see, now we have drawn the sine graph. Okay, we've drawn the cos graph. Now let's try and see if you can then interpret these graphs that have been given here. In this case, the sketch, you're given a sketch. See, that's where you do your interpretation. The sketch is given to you. The diagram below shows the graph of f of x equals to cos 2x. All right. Now, they want us to, and we're given an interval, so the interval is the whole graph from 0 degrees to 360 degrees. Wow, so that is from 0 up to 360 degrees, that is given. You can see that the graph here, it stops here, it doesn't have an arrow. Now 1.1, they say on the same set of axes, we want you to draw the graph of g of x equals to x minus 45 degrees for the whole interval from x 0 degrees to 360 degrees. So in other words, the one graph is drawn, the other one must be drawn on top of this one, okay, in the same set of axes. So then you take your calculator. Then you put in this graph in your calculator, x minus 45, which is the shift to the right. You must know if there's a minus there, the graph has shifted 45 units to the right. If it's plus, it has shifted 45 minutes to the left. Now, in this case, it's 45 degrees to the left, and this one is to the right. Then for that interval. So you can put the values of x there, 45, 90, 135, all those values, put them in, and then try to draw that sketch. But in the next slide, what I've done there, I've tried to draw that sketch. That sketch, it's now there. So what do we do? In this case, we have the G graph, it's there. The F graph is there. At that point, it was there. I think it was negative 0.7. At 45, it was this point. We have that point here. Sorry, we have got that point at 145. At 90, it was there. 0.7, and then from there we have all those points. Now, before we continue with the questions, the first thing that I want you to check is the F graph and the G graph, they meet there. Can you see? That is the point of intersection. So if they say, where is the F graph equals to the G graph? Then you give them that point, which is going to be at 45. Again, they meet there, but I don't know what that point is. We don't also know what that point is. Unless if I was given one coordinate, I'll be able to get the other one. Another point is this one. I know it's at 225 and 0. That's where they meet. Another point there where they meet is there. All right. Okay. The questions that they ask, this is the question that they ask. The first question. Write down, use the graphs to determine the following. The first thing there, they want you to find what is the amplitude of G. The amplitude of G, how high is the G graph? Okay, and how low is the G graph? So if I look at my G graph, the G graph is that orange one. So the G graph, the highest point there is going to be 1. So I'm talking about that point there, so it's going to be at 1. So that is my highest point. So my amplitude and the lowest point there will be at -1, but I don't write -1, amplitude positive. So I'm going to say my amplitude is going to be equals to 1. So amplitude, it's 1. And that's 1. Then how do I check my amplitude here? You'll have realized that my G graph was, if you can quickly go back, my G graph has an amplitude of 1. The value that is there is 1. So that is my amplitude. Okay, I can just read it from the equation that has been given. Right. So the first question there, it's 1 mark there. We're saying what is the amplitude of the graph. So that's very clear. The next question says the same graph. Can we then use the graph to determine the following? That is the period of the F graph. So what is the period of the F graph? Right. So the F graph was given as cos of 2x. Y equals to cos of 2x. Sorry, let me write it here. Y equals to the cos of 2x. All right. So if you can just quickly go back, you can see that the graph is cos of 2x. So now they want the period. So remember, if I need a period of this graph, I first look at this value here. Remember, the period means that is a complete graph. So the cos, if I talk about cos complete graph, so that cos graph will go like that and the graph ends here. So if you remember the original cos graph, it stops there, right? But if I look at this now, this graph is now repeating itself. Oh, see, so what is, when you talk about the period, where does the complete graph stop? The first complete graph. So my first complete graph will stop at 180 degrees. That's my complete graph. So you can see it stops at 180 degrees. So the period of this graph will be 180. But how do I get this? So I'll say, if I need a period, I'm going to say the period is equals to 360 degrees divided by that value there. Divided by that value, and that gives us 180 degrees. That is the period of the graph. If I had y equals to cos 3x, then I'll say 360 degrees divided by 2, which is going to be, don't confuse that with the number that is there. If I'm given a 2 there, that is not going to be divided. 360 is not going to be divided by the 2. That 2 there will tell me how high the graph will be and how low the graph will go. So at 2 and also at -2. All right. So please don't confuse the 2 and that one and that one. So please, okay. In the exam, you are only going to be given one of them. So it's either cos 2x or 2 cos x. We can confuse you by giving you too many parameters. Okay. Right. So the period of this graph here will be 180 degrees. Safe enough. Okay. Right on. The next question, remember, you're answering questions based on that graph that you have drawn. Okay. And the graph that has been given to you. Now they talk about the range of G. Now, don't confuse the range with the amplitude. The range means that what is the value, the minimum of the graph, and what is the maximum of that graph. Sometimes we find that the graph can go below that and it stops there, and it can go below that. But the range will now be written in this way. So the range, think of the range in our graphs. Okay, in our traditional graphs that we do in algebra, the algebraic graphs. So the range is the y values of the graph. So in other words, if I'm talking about the range of that orange graph, the range, the top part there, it's at 1. And the bottom part there, it's at -1. See? Right. So I've got 1 and negative 1. How do I write it? So it will be from 1 to negative 1. But how do I then write it? I'll write it as the y. The y will be less or equals to 1 because it's from 1 down, less. Then it's also going to be greater or equals to negative 1. In other words, it's more than negative 1, but it's less than 1. So it is between, the graph is between 1 and minus 1. Okay, but we must write it properly. That is the way on how we are going to write that and our answer here for the range. Okay, so the range for the parameters, we can give you 2 marks there because then you have to find the 2 parameters, the 1 and the minus 1. So the range will be between those 2. Okay. The next question says use the same graph, but now you have to find for us f of 135 degrees minus the g of 135 degrees. Easy. Because f of 1 means that I must substitute the value of x by 1. Okay, let me say f of 90 degrees will mean that I must substitute the value of x by 90 degrees. Then I must get my final answer. So f of 35, remember the 2 graphs that we're given? It's the cos of x, it's y equals to the cos of x for the f graph, it's cos of x, and the g graph was the sine of x minus 45. Okay, let's just confirm that in our slides. In our first one, that's correct, x minus 45 and cos 2x. So I'm now going to substitute. So what do I substitute? I'm going to say the f graph, I'm going to substitute the cos of 2 times 135 minus. With the g graph, I'm going to substitute sine into 135 minus 45 degrees. Then I'm going to use my calculator. So the first one is the substitution, from mark for the substitution. The next one is for the answer. So that will be the cos of 270, close the bracket, minus the sine of 90 degrees. Then I close the bracket, and my answer there is going to be negative 1. So it's 2 marks for that. So even 1 mark for substitution, 1 mark for the final answer, because you're using a calculator to do that, and that is quite easy. Okay. 1.1.5 says you're still using the same graph, but now they want you to get the values of x for which this graph here is equals to 1. So I'm going to look for the f graph. So the f graph, I want the values, see the values of x between that. So I need all the values from 0 to 360 degrees. So where is the f graph at 1? It is at 1, let's check. It is at 1 here at 0 degrees. It is again at 1 here at 180 degrees. Where again is that value at 1? It will be at 1 again here at 360 degrees. You see how easy these questions are. So what should I write as my solution? The x will be having how many values there? We'll have a 0 degree. Again, where do we have it? At 180 degrees. Again, where do we have it? At 360 degrees. So these are the 3 values, and each value has got a mark. Okay, so we know we have those 3 values with 3 marks there, just to see and to look at that graph and then check where the f graph, they're talking about the f graph, where the f graph is equals to 1. Then we need the x values. Remember, x values are degrees. So the answer that you must get there will be the degrees. Okay. If I substitute my value of x by 0, by 180, by 360, I get a 1. That's what it's talking about. But the values of x for which f of x is less than 0. which values of x will f of x be less than 0? Now, pay attention now. The interval now has changed. It means that I'm working from 180 degrees. I'm not working there. So I'm working from 180 degrees to 360 degrees. That's where I'm working. So what am I going to do here? I'm now going to say, where is the graph? If I say less than 0, and I'm talking about the F graph. So in other words, I'm talking about the black graph. So I'm talking about that black graph. Where is the black graph? Below the x-axis. So when they say less than 0, it says below the x-axis. X. So where is this graph? Below the x-axis. Now, but we need the values of x. From which value of x to which value of x is the graph below the x-axis? Now, if I check this graph here, here it is above the x-axis. The black graph is above the x-axis. So from 180 to 225, the graph is above the x-axis. So that is not going to be my solution. From 225 to 315, the graph is below the x-axis. So can you see? I already have my answer. From 315 to 360, the graph is above the x-axis. So that is not my solution. That is not my solution. So what is my solution here? So my solution is going to be from 225 to 315, the graph will be below the x-axis. Mathematically, how do we write it mathematically? So I'm going to say, I want to say it is between the two values. So I'm going to say, because this is less than, you can see that's less than, there's no equal sign, which makes it very interesting. So if there's no equal sign, then my answers must not have equal signs also. So there are two ways in how I'm going to write my solution. So I'm going to say the x value, because I'm talking about the x values now, the x values will be between, so if it's between, I write x in the middle, I write less than, the number on my right must be there, 315 degrees. The number on my left, which is 225, must be this side also on my left. The x must be in the middle, all the signs must be less than. So that is in the middle. Do you see, don't put equal signs because we're saying f of x must be less than 0. So if they said less or equals to, then I'll put that equal sign. So in this case, I'm not putting any equal sign. So my solution will be like that. Or I can write my solution as. Then I'm going to put a round bracket because the values are not included. So I'm going to give 225 degrees. And then I'm going to say 315 degrees, meaning that that value also it's not included. And if I put a square bracket, it means it is included. So this is the two ways on how I'm going to write my solution. Okay, the last question there talks about f of x and g of x multiplied together to give us greater than. So what does this mean? It means that where are the two graphs? When I multiply the two graphs, can I get a value which is less than, which is greater than 0? So now let's check quickly. This graph is above the x-axis. I'm going to put a plus and a plus and a plus. This value is below the x-axis. I'm putting negatives. This value is above the x-axis. I'm putting a plus, a plus, a plus, and a plus. This value here is negative, 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 positive, 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 negative, 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 negative. This one negative, 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 negative. This is plus and plus. So let's check. Where are the two graphs? When I multiply the two graphs, where do I get a positive value? From here to there, I'm multiplying a positive multiplied by a negative, which I'm getting a negative. So no solution for this. Here I'm multiplying a positive. See a positive. I'm going to stop here first. I'm multiplying a positive and a negative, which gives me a negative. No solution for that. Okay. Here I'm multiplying a positive and a positive, and a positive here, and a positive. So between here and there, we have a solution for the greater than. Meaning that my solution will be x less than 225 or equals to, and x greater than 135. That's my solution. Again, if I multiply the negatives up to here, negative and negative, that's my solution. X will be less than 315 degrees, and x will be greater or equals to 225 degrees, because I'm multiplying a negative and a negative up to here. There I'm having a plus and a negative, so I'll get a negative, not a solution. So my solution will be here and there. Okay, so I can put my solutions like this for these 2 degrees. All right. So that part of the question, you must also go and do. This question are also very, very important. And this one talks about the gradient. So the gradient of that line can be, remember when we talk about the gradient which is greater than, so the gradient of the F graph will look like that. And they're talking 0 to 180. So it's 0 to 180. The gradient of that line will be positive. So the gradient of that line will be positive from 0 degrees up to 180 degrees. So the solution for that will be x is 180 degrees, and that will be 0, it will be 90 degrees. So that's the gradient of the line. Derivative means gradient. So the gradient of that graph, it's a positive gradient. Greater than means positive gradient. So we're having a positive gradient between this number and that number there, because that gradient will be positive for the F graph. Thank you so much. We've done a lot today. It's now back to you to practice on these questions that we have done. We have done. Go back, listen to the video again, and then practice on these questions. You'll ultimately get them right. And thank you so much for tuning in.